Okay, guys, so this is this video or this part of the notes is going to be broken down into two parts. The next thing that we are going to be working on is the power of a quotient. Now, remember, quotient, we talked about that already. Quotient means that we're dividing powers. So division, quotient means division. Now the power, we're talking about the exponent part of dividing those powers. So when you see it put together, maybe you could see something like x cubed over x squared, which is something you saw yesterday, but now we're bringing it out to another power, another exponent. All right. So let's look at it in the expression form. In expanded form, remember, anytime you have an exponent, that just means that you're going to multiply, you're going to be multiplying that base this many times. Now, I realize it's seen this way here, but I would rather just use some parentheses like so. 3 times 3 because of the 3 squared. And then now the squared, since it's on the outside, you have to multiply it by whatever's at the top, but also whatever's at the bottom now. Whenever we were looking at product power of a power, remember the exponent on the outside applied to everything on the inside. Like for example, say we had x squared, y cubed, and a squared there on the outside. That meant that this squared was going to apply to this exponent, but also this exponent. So we showed it to you this way, x squared, squared again, and then it's separated to y cubed with the squared. Now it's similar, but this time you have numbers on the top and the bottom in the numerator and the denominator. So let me go back. Now that squared is also going to apply to the 5s. So since we are multiplying that 3 twice, or we're multiplying the same base twice, that's where the 3 squared comes from. 5 times 5, we're multiplying the same base twice, 5 squared. Now, once again, I've been showing you guys how to simplify it just in case you end up seeing it on the STAR test. Simplify. 3 squared, we know 3 squared means 3 times 3, which is 9, and 5 squared, 25. Always simplify if possible. So when I type it into my alpha y equals 9 over 25, nothing changes. So this is the simplest form right there. Okay, moving on. This time we don't have just numbers, so this cannot be simplified any further, or you cannot type this into your calculator at the end. But we do have m to the power of 4 and 8 to the power of 4. This exponent of 4 applies to both m and also the 8. So how would that look expanded? That means we are going to multiply the m 4 times 2, 3, 4, and also the 8. Oh Lord, 8. Forgot how to write an 8. 8. 8. Now we are multiplying the same base 4 times, and we are multiplying the 8 4 times, making this m to the power of 4 over 8 to the power of 4. 8 to the power of 4 can be simplified. Here we had numbers on the top and the bottom, but here we have that couple of numbers. So let's see what 8 to the power of 4 gives us. 4,096. Now m to the power of 4 stays the same. And we said 4,096. So you could see it either or, each way there. Next, we have negative. That's something special that we haven't seen. But anytime you have a negative, just try to apply it to that top number and then you'll be good. So we're talking, or they're asking us to make 2 groups of it. So I'm going to type in my negative a times negative a, okay? And then 9 and my 9 right here. Now we have two A's, but then also think about this. We're multiplying two negatives. We are multiplying two negatives, and that is also, so you cannot type this into the calculator, so you can't see if the calculator is going to remove the negative or not. But just think about the fact that two negatives, negative times a negative, makes a positive. So that's going to be a positive A. And since we are multiplying it twice, A squared. 9 times 9, 9 squared. Now you can simplify this denominator. You can simplify the bottom part of this fraction. 9 times 9 gives you 81. Okay. So compare the first and the third, rows and describe the relationship. What you are doing here is you are distributing. Think about it like this. Say every base has to have its own exponent. What we did is we ended up taking that 2, multiplying it by 1, but we take that same 2 and multiply it by this little 1. So 1 times 2 gives me that 2. 1 times 2 gives me the bottom 2. You're distributing, you are multiplying that denominator. So let's see, distribute. Outside exponent to each exponent in parentheses. Okay, parentheses. It's supposed to have an S there. Now, there is one rule that didn't apply, or it applied there to that third column. We're talking about those negatives. So if, big if your base, this is something you will have to know just because you can't type in a base if the base is a variable into the calculator to see if it removes the negative or not. So you do need to know the rule now. If the base is negative, when the exponent on that base is even, if you have an even exponent, it's going to be it's going to turn the whole base positive. If the base is negative and the exponent on that base is an odd number, odd exponent, it'll remain negative. So look at this one right here. Because that exponent is, writing it like so is the same as having a negative A squared. Here's my 9 squared. So this part right here, my base is negative, but the exponent on that base is an even number, making this whole thing positive. Okay. All right, and this is the rule. Remember, every base needs an exponent. So I'm going to put a little 1 here on the X, 1 on the Y, and you're taking that outside exponent and distributing or multiplying it by each exponent inside. Okay. All right, so let's see a few examples. Move on. Oh, no, not that one right there. Okay, so we are going to, since we have different bases, I'm going to make this a little easier on myself by, well, they're all numbers. We're just going to keep it together for this first example. Make sure every base has an exponent, 1 and a 1. We have an exponent on the outside of our parentheses, so make sure you circle it and do not forget about it. And I'm just going to, instead of making one long parentheses, I'm going to break it apart. So 5 to the power of 1 is what's on top. And then 4 to the power of 1 on the bottom, but they both have that exponent of 3. So we grab that 3 and we're going to multiply. We're going to grab that 3 and we're going to distribute it. I'm going to circle it around right here. Next step. So that creates 5 to the power of 1 times 3 at the top, 4 to the power of 1 times 3 at the bottom. 1 times 3 is 3, so that gives us 5 cubed. And 1 times 3 is 3, 4 cubed. Now you may be able to see this on the SOAR test, but once again, you want to try to simplify it. So 5 cubed, if I type that into my calculator on 5 math 3, 125, 4 cubed, 4 math 3 over 164. So 125 over 64. Now remember, you always want to simplify these fractions if possible. So alpha y equals 125 over 60. Oh Lord. Delete 64 right there. And it remains the same. So this actually becomes my final answer. Simplify if possible. Since we are dealing with fractions, simplifying, reducing is going to be a big thing here. Okay. Next part. This time we have not just numbers, like in the first example, we have numbers with variables. So our bases are different. I am going to break this one apart. Make sure that every base has an exponent and circle that outside exponent so you do not forget about it. Okay, I'm going to actually do everything a different color. So I'm going to start there with that 2 to the power of 1 to the power of 7. That's my outside exponent. Now, since this is the top part of my fraction, remember to convert anything to a fraction, you put it over 1. Okay. And you grab that outside exponent, 1 power, 2 exponents, you multiply the exponents. Okay. So 2 to the power of 1 times 7, still over 1. 1 times 7 is 7. So 2 to the power of 7 over 1. Still on the top side of my fraction. And then 2 to the power of 7 simplifies to 128. We're done there. There's nothing else I can do. I'm leaving it over 1 for a reason because I'm going to have to put everything back together next. Now we have x to the power of 1 multiply. You have that 7 exponent on the outside. Since it's at the top of my fraction, we're going to just go ahead and put it over 1. You have an outside exponent, so make sure if you have 1 power to another power or 1 power with 2 exponents, you multiply those. So that creates x to the power of 1 times 7. It's still at the top of my fraction, so I'm going to leave it over 1. 1 times 7 is 7. X to the power of 7 over 1. Nothing else I can do there. Next one, we also have a y, but notice that the y is at the bottom of my fraction. So y to the power of 1, it's in parentheses, leave it in parentheses for now. And that 7 is my outside exponent. But since there's nothing up top, this time it's going to be flipped around. It's 1 over that. So 1 over. We have 1 power with 2 exponents. So I'm going to grab that outside exponent and distribute it or multiply it, creating y to the power of 1 times 7. 1 times 7 is 7. And now, since I can't do anything there, I'm going to go ahead and come out to the side, or no, just go to the bottom and put everything all back together again. I'm going to choose a different color. So these are fractions. I'm going to start with my fraction bar. The 128 is at the top, leave it at the top. X to the power of 7 is at the top, leave it at the top. Y to the power of 7 is at the bottom, y to the power of 7. And there is my final answer. Next one. We have the same base, but you do have this outside exponent. So there's no need to separate into different categories, but we do need to distribute this. Each base has an exponent, so we're ready to go. The top part of my fraction is b cubed to the power of 8. And the bottom part of my fraction is b squared to the power of 8. Okay. 1 power with 2 exponents. Remember, you're going to multiply 1 power, 2 exponents, grab that outside and multiply. So here we go. The top part of this becomes b to the power of 3 times 8. Bottom part, b to the power of 2 times 8. 3 times 8 will give us 24. And 2 times 8 will give us 16. Now we are dividing 2 powers with the same base. So what do? This is the part that we learned yesterday. 1 power or the same power dividing. So what you do is subtract the exponents. 24 minus 16, becoming b to the power of 8. Next, one more, and then we'll do the other examples in class on Monday for Ms. Ramirez's class. For Ms. Rona, you guys will have a part 2. Same base, make sure everything has its own exponent, and we're going to circle that outside one. Now, since we have the same base, there's no need to break it apart into sections like we did up here. But I am going to break apart this parentheses instead of making it go around everything. So the top part of my fraction is x squared. Outside exponent is cubed. Bottom part of my fraction is x to the power of 1. Outside exponent is cubed. 1 power, 2 exponents, multiply the exponents. 1 power in the parentheses, 2 exponents, multiply the exponents. So the top becomes x to the power of 2 times 3. Bottom becomes x to the power of 1 times 3. 2 times 3 will give us 6. And then 1 times 3 gives us 3. We are dividing 2 powers with the same base. Remember that fraction bar, think of that as your minus sign, right? So we're going to, even though we're dividing here, we're subtracting the exponents. Laws of exponents apply to exponents only. So I'm going to take that 6 and subtract the 3. 6 minus 3 is 3, and your final answer is x cubed. Okay, now this is a big one. We'll leave that one for tomorrow or for Monday for my class. Ms. Ronas, get ready.